we were able to record 103 species of the different butterfly families. And along the areas that we sampled, you can see that the species richness was more or less, good. And we were happy that at least the areas, the ecosystems, the landscapes that we sampled had good representation of butterfly species richness. So we were also interested, as we have said, butterflies are pollinators, although most people don't know, even the communities. Most people know that bees are the pollinators. But you know what? We are being told that bees are disappearing, the bees are dying. What do? We have to also understand the alternative pollinators. So we were happy to see that majority of the species that were recorded in the Tana Delta are flower visitors that feed on nectar, and a few in the nymphaliid families. These are the caraxes, the very strong butterflies. They feed on fermented fruits. They also feed on tree sap, among others. We even have a picture of a caraxes butterfly feeding on a dead snake. That was good, and again, understand that this area, the Tana River, is a savanna kind of ecosystem with a lot of acacia species. And one of the butterfly families, the skippers, they actually are recorded as pollinators of acacia. I just put this picture here to show you that butterflies are very key in the pollination of acacia. And you know that acacia, other than the ecosystem services in those dryland areas, the communities harvest the pods and they store them so that when it's dry, their livestock can have food. So what about the conservation status? We found that among those butterflies, we have 3 species that are endemic to Kenya, found nowhere else except Kenya. And in the IUCN status, 53 species were recorded as of least concern status, and 44 species are not yet evaluated. And with this number of species, we found that they form 11.4% of the Kenya's butterfly population. Currently, we are standing at around 903 butterfly species in our country. So you can see that this delta is contributing over 10% of the population of butterflies in this country. So what is the way forward? The way forward is that we need to start, and especially our brother from KWS, you start also thinking beyond the big 5. Think of these indicators, think of these pollinators. As you've seen, we see giraffes feeding on acacia. What if the butterflies disappear? Where will the big 5s feed on? I mean, there'll be no acacia, so there'll be no giraffes. So as we were challenged, we need to see the connectivity of nature so that we don't just focus when we talk of big 5, or we also consider these less known taxa, but they are the little things that run the world. Without them, we are all gone. I'm going back to my. So, and with that, because of time, I say thank you for listening, and thank you for coming.
Sawa Daktari, thank you for the challenge that we need to think beyond the big 5. Anyone with questions, I think we are going to address them towards the tail end of the presentations. And let's give another round of applause. So the next presenter, I don't know if he's in the house, that is Oliver. Okay, so I think we'll move to Alex Musyoki. Okay, Karibu. You have 8 minutes.
Let me put another version of the presentation here. Thank you. My name is Alex, and I'll be talking about indigenous knowledge and associated farmer practices that have been used in Murang'a County to conserve pollinators of pulses and indigenous living vegetables. And in this work, I'd worked with Dr. Samita, Dr. Karanja, Dr. Darani, and Dr. Kyoko. So welcome. So for introduction, we know that pollination is the transfer of pollen grains to the anthers, and it's essential in maintenance of biodiversity and food security. And globally, it has been documented to contribute more than $500 million annually. And pollinators have been documented to be declining, and this because of natural habitat loss, because of landscape fragmentation and degradation, pests and diseases, climate change, pollution, and invasive exotic species. And into pulses, pulses are those crops that are harvested for consumption as dry seeds, and they have been documented to be high in protein content, unsaturated fats, and soluble fibers, while leafy vegetables are those crops or plants that have been accepted and they are used as vegetables, and they are rich in vitamins and essential minerals. On the other end, indigenous knowledge has been documented as the cumulative knowledge, know-how, and practices that have been maintained and developed by the local communities. Mark the word maintained and developed, because sometimes they are not original, but they are just like survival tactics, but they are maintained by the local communities, and they are as a result of interaction between the population and the local environment. To the problem statement, farmer practices and knowledge on pollinator conservation has not really been documented, because if you look into many studies that have been done, they look into pest control, but not indigenous knowledge on pest control, but not pollinators. And therefore, there is need to correctly and scientifically challenge farmer practices, because like you have seen, the challenges facing pollinators, more than 80%, they originate from human activity. So if we don't challenge our farmers to take the right practices, then we'll not be able to create the correct pollinator conservation awareness. The objective of this study was to document farmer knowledge on beneficial organisms, pollinators, and associated practices in pollinator conservation in local farms. This study was carried out in Murang'a South, in Murang'a County. And the study design used, we looked for farmers, and we had farmer focus groups, and used a questionnaire. And in the questionnaire, apart from getting the biodata, those information about the farmers and all those, our main agenda was to get information on the farmers' knowledge on beneficial organisms, pollinators, and their conservation strategies. What are they doing in the farms to ensure they conserve the pollinators? And after we got the data, we analyzed our data in two ways, where we had descriptive analysis using Excel, and also we had statistical analysis in R using chi-square to get the relationship between maybe education and the end practice that they were doing, and their knowledge on pollinators and beneficial insects. To the results, after we did our regression analysis using chi-square, we were able to authentically say that the level of education did not affect farmers either belonging to farmer groups, training, or extension services. However, their age affected their belonging to such groups, where we found that more of the older people, they joined farmer groups, they had received training, and also they consulted extension officers. And this could be because when they are in those farmer groups, they can easily be visited by agricultural extension officers and then give them the training and offer extension services in their farms. In relation to the knowledge on beneficial organisms on the farm, the level of education and age did not affect the knowledge on beneficial organisms. Likewise, to the knowledge of flower visitors. However, the level of education affected the knowledge on sweat bees, the Lactidae. Those are, for the old age, they did not understand the sweat bees to be pollinators. However, for the young and educated, they were able to positively identify the sweat bees as pollinators. Okay, so this is just about these are descriptive analysis on the crops that were grown there, and the indigenous vegetables, they were more grown by the older, while the pulses were grown across the board by all the ages. And the young farmers, especially 29 to 39, they did not belong to groups, hence they didn't receive any training. And for the beneficial organisms, the farmers were able to identify bees and birds and butterflies as the major pollinators, while for the wasp and sweat bees, they were not conversant with them. And on pollinators, the bees and the horseflies, they were the most common group, while the sweat bees, like I said, they were only positively identified by the young farmers. And on pollination conservation strategies, the